to get rid of this channel. There. Okay, now you won't be able to answer the question until I hit this triangle. So if it's not open, sometimes you have to yell at me. It's just a little. Okay, remind me to do that. Okay, so now it should take all your answers. Okay, so we should have 27 responses up there. This isn't a real heavy thinking question. Okay, I only have 26. All right, so if somebody's not working, can I not subtract? 29 minus 2 is 27. Right, last time I checked. Somebody isn't getting it recorded. Okay, so look at your clicker, and it should, when you press the letter, it should go check, check, check. I forgot about the checks. Okay. Yeah.
Mine's not letting me do the letters, it's only doing the numbers, and I pressed the ABC numbers.
Okay. Let me do it. Okay, you have to put in the channel number. You missed that. That's what happens, girls. Okay, so you got to put in 31, and then okay. And that's why he was wanting the number. Okay, now it should work. You tell them biology, it's real important. Okay, did it good take it? Yay! Okay, so then I'll hit this, and we'll get all the answers. Okay? Now, every answer is correct on this question. Okay, even though you were all supposed to put purple because that's mine. But, you know, that's okay. Okay? Any questions? We're clicker savvy now, right? Okay. Why isn't my... There we go. I just hit it once, right? I don't know, some days it lets me use that keyboard, and other days it doesn't. Okay, now let's try this. Okay, there we go. Okay, when we make covalent bonds, which is what we're going to do 99.99% of the time in here, we're taking one electron from one atom and one from the other. We're putting them together, and we are sharing those electrons. Those electrons do not always get shared equally because atoms differ in something called electronegativity. So you should have talked about electronegativity even a little bit in general chemistry, and that is a measure of how an element attracts electrons. Okay? Who knows what the most electronegative element on the periodic table is? Fluorine. It's really important to know that for like 100 things, okay? So if you don't know that, make yourself learn that today. Okay? And you spell fluorine F-L-U-O-R-I-N-E, not F-L-O-U-R-I. That's fluorine, not fluorine. So if you think of it as fluorine, it'll help you spell it right. Sometimes on mastering chemistry, sapling, etc., when you spell it wrong, it's wrong. So that's why I'm mentioning it. I'm not going to be like overly picky about that. But okay, here is the electronegativity scale. It was developed by Pauling. You probably heard about Linus Pauling. He's done like a lot of stuff. Okay, and it doesn't have every element on the table up here. Okay, but it has fluorine, which is 4. That is the biggest number on the table. And it's important not necessarily to know all those numbers. You'll get a feel for them as we go. But to notice that as you go from left to right, it increases. And as you go from bottom up, it increases. Okay? So what's happening is it's increasing towards fluorine. Now, fluorine is before the noble gases. We kind of kicked them out, didn't we? Why? How many covalent bonds do noble gases make? Practically 0. Now, I have to say practically because people went in there and forced those things to react. Okay, they used to be called the inert gases back when I was a little student. I'll add the little. They were called the inert gases, and people did things to them, like put them at super high temperatures and under all these weird conditions and force them to react and make compounds. And so because of that, they're not really inert. But typically when you find helium, neon, argon, those are the main ones that people will use. When you find those, they're just the single atom. It's not a compound, okay? Neon is used in those lights, okay? Everybody's seen neon lights, right? Okay, well, a good friend of mine, her son is an artist out in Las Vegas, and he designs those signs. Okay, pretty cool. Well, he told us that they actually pump the neon out of the sign and pump it into a new one. It is so inert that even being radiated with electricity for many years, it's still neon, just plain old neon, and they can keep reusing it. So it's kind of cool. And y'all know they put argon in headlights and all that kind of stuff now. Okay, so here we are. These are the elements we're going to be concentrating on. We get a few metals over there, okay? But remember that what makes a covalent bond, the two atoms are non-metals, okay? If you have a metal and a non-metal, it's ionic, okay? Pretty much. We're not going to worry about those metallic bonds and all that. Okay, so a good rule of thumb is the greater the difference in electronegativity between the two atoms, the greater the polarity of the bond. Okay, so while you're figuring out which bonds are polar and which bonds aren't, you might want to use that table. Okay, so here is fluorine. Okay, that's F2. Remember, all the halogens are diatomic. Remember that whole deal? Okay, here's a little Lewis structure of F2. And is that a polar bond or a nonpolar bond? It's nonpolar because they're both the same electronegativity. So the difference is 0. Okay? What about HF? Okay, well, fluorine was 4. What was hydrogen on that deal? Was it 2.1? Okay. I know a couple of those numbers, but not a whole lot. Okay, so the difference between 4 and 2.1 is kind of a big number. That's a polar bond. Okay, if I asked you who has the electron density, who has more of the electron density, fluorine or hydrogen, which one would you pick?
Fluorine.
Why? Why pick fluorine?
It's the most electronegativity.
Because it's the most electronegative, okay? Sometimes we write these little funky partial things, is what they're called. If you take advanced calculus, you'll get to do partial derivatives. But it's like a lowercase delta, and we put a plus and a minus by who is plus and who is minus. So more of the electron density is on the fluorine, so it's delta minus. Less on the hydrogen, so it's delta plus. Okay. All right, now here's just a plain old CH bond. What is that one? Okay, well, hydrogen was 2.1. What was carbon? You can look. I mean, you got the thing printed out, don't you? 2.5, okay. So this is going to be nonpolar because the difference, it's not identical, but it's not a very large difference. So really the rule of thumb is if it's less than a half, it's nonpolar, the difference. A half to 1.6 is pretty much polar, okay? If you get above 1.6, you start getting into ionic. Okay, any questions on that? So it's a way that you can decide if a bond is polar or not. Okay, identify the compound with ionic bonding. Okay, so here's your first real. The other one counts though. I'm not going to not count it. Okay, we're up to 21, so let's get to 27. Okay, we're all up there. Good deal. Okay, yep, it's B. Okay, sodium bromide. How do you know that?
Metal, non-metal.
You have a metal and a non-metal. All the others, even if you don't understand how they're hooked together, they don't have any metals in them. They all have non-metals. Okay, remember that diagonal line goes between metals and non-metals. And up here, they're color-coded for you in yellow. I don't know how many students I've asked if it's a metal or a non-metal, and they didn't figure that out yet. I'm telling you. Okay, we're going to have these diagrams called electrostatic potential diagrams. This is what they look like. They're colored, okay? This is the one for HF, our very polar bond that was on the other slide. And you'll see that the red side is high electron density and the blue is low. Now, the reason that we use these and we talk about them is because let's say you're something negative like hydroxide ion. Y'all have heard of hydroxide ion, right? We're going to be worrying about how is it going to react with this molecule and how does it work? Well, your hydroxide ion, if it's running around, it's going to come over here. And is it going to go to the blue side or the red side? It's negative, so it's going to go to where it's positive. Opposites attract. That's the whole thing, okay? So if you're negative, you're going to go to the H, the blue side. Okay, that makes sense? That's why we talk about them. Now, yeah, see, it did something really funny when I exported it. So it usually is just a lighter shade. I couldn't fix that. It was like not happening. Okay, and you'll notice that I got delta plus and delta minus like I showed you earlier, but I also have this little red arrow with a plus at the end. It's another way to show the polarity of the bond. The electrons are being pulled towards the fluorine, so this side is a little bit positive. Does that make sense? Okay. We kind of will use both ways. I don't have a preference. I kind of tend to do it. Okay, so red is high and blue is low. Bless you. I got Kleenexes too. Okay, which bond is more polar? Let's see how you're doing. So I've got a CH or a CCl. What do you think?
Chlorine in it.
Mm-hmm. Is it gonna, yeah, it's gonna circulate, okay? Because the difference in electronegativity is greater between chlorine and carbon, okay? You'll notice that there are some CHs on that molecule too, okay? All right, so here is HOH or HH. So the HO, right? That bond is gonna be more polar, okay? Remember, if it's the same atom, it's 0, right? All right, so we've got HCl or HF. Fluorine is greater electronegativity than chlorine. And then we've got 2 chlorines or a chlorine carbon. Chlorine carbon. Okay, we're looking for differences. Difference between chlorine and chlorine is 0. Okay, now what is the direction of the polarity? Okay, so if you look at, I don't know if the little arrows are going to come up. If you look at chlorine carbon, which way are we going to go? If we're going to draw that arrow, I'm going to draw it if it doesn't come up. To the chlorine. Okay, it is. All right, does that make sense? You see why we did that way? Chlorine is higher than carbon. Okay, HO. To the O, right? Oxygen is more electronegative than hydrogen. Even if you don't know the numbers, you don't need to know the numbers. You need to know which one is more electronegative. Okay? This is why water does that thing called hydrogen bonding that we'll talk about in chapter 2. Okay, HF goes to the You already know that. Fluorine. And this one is kind of a repeat of the first one. Okay? We're with it? Okay. And why, again, is this important? Well, if you have this compound and you are OH minus, hydroxide ion, and you're going to come in and you're going to react with this molecule, are you going to react at the chlorine or the carbon? You're negative, so you're going to react where it's positive, which is the carbon. Okay? It always works that way. Okay? What if you are H plus? Okay? H plus is positive. Okay? And you're looking at water. Where is the H plus going to go? To the H or the O? To the O. Okay? Because it's negative. Okay? It's got more electron density. Is that making sense? Okay, that's why we talk about this, because this is real important. The areas that are nonpolar, like the CH3 part, where you have a carbon and 3 hydrogens that it's bonded to, that part is very nonpolar and reactions don't occur there very readily. Okay? You can do some stuff there, but not very much. All the action is where there's polar bonds. That's where all the good stuff happens. Okay, which bond of these 4 do you think is more polar? Ooh, you were faster on this one. We're up to 25 already. All right. Hope all those examples helped. Yes, C. Why is C more polar than A? It's a fluorine-carbon bond, and this is a chlorine-carbon bond. Fluorine has a higher electronegativity than chlorine, so the difference is going to be greater. Greater difference, higher polarity. Okay? Ooh. I don't know what that was. Okay, so what we're going to be doing is working on drawing Lewis structures. Did you do some Lewis structures in general chemistry? Okay. You may not have done very many. Did you do like water and few things? Okay. Well, this is going to be super expanded from that. Okay. But hopefully that'll help you. The big thing to always remember is the octet rule. Okay? Atoms want to share electrons so that they will have 8 electrons around them, except for hydrogen. And I mentioned there are other elements that would not do it either, but hydrogen is one we're going to use a whole lot. Okay? So hydrogen only has 1 electron, so it can only make 1 bond. Do not make multiple bonds to hydrogen. Okay? Do not make more than 1 bond to a hydrogen. Okay, we're going to use a line to stand for a pair of shared electrons. So each time you draw a line, that means 2 electrons. Remember, 2 electrons make a bond. 1 from one atom, 1 from the other. They're like shaking hands. Okay? Now there's going to be something called lone pairs. Have you heard of that? You should have heard of that if you did some stuff in general chemistry. Probably with water. Okay, we're going to write 2 dots. Okay, 2 dots is the lone pairs. And we'll talk a little more about those things. Okay? But that's basically how we're going to do it. Okay, this is water. Okay? You've got an O, and it's got 2 lines, each to 1 H, and then 2 lone pairs on it. So you have bonds and lone pairs. How many electrons are around the oxygen? 2, 4, 6, 8. Okay? That's how, so you can check and make sure that you don't screw up. Okay? You're writing on a piece of paper. I mean, whatever you write down is going to be what's on the paper. So, just keep that in mind. You can make 15 bonds to oxygen if you want. It isn't correct, but you can do that. Okay, the main elements that we're going to be using. are going to be carbon, hydrogen, oxygen, nitrogen, and the 4 halogens, which are fluorine, chlorine, bromine, and iodine. Okay, those are the main ones we're going to use. We will talk about sulfur. We'll throw in some sodium and lithium. We're going to throw in some metals, okay? But these are the main ones that are going to be in our molecules. We're going to use those other things to do stuff, okay? We even use a little boron. Okay, so here is a table to help you draw structures, okay? Here I'll get southeastern blue, maybe. Okay, so hydrogen has how many valence electrons? No, valence electrons. It only has how many electrons? 1, okay. Y'all are freaking me out, aren't you? Okay, so it can make, there's the duet rule, if that's what you're thinking of, where a hydrogen could only have a maximum of 2 because it's the 1s orbital, all that stuff. Ooh. Okay, all right, so we're going to do hydrogen, and I'm going to draw a picture, and that picture is going to have a dot. And that dot is hard to color in when you have a skinny line. That dot stands for an electron, okay? So what does that tell you? That tells you that hydrogen has how many places to bond? 1, okay? So you can only get 1 bond on every hydrogen.
Are you
Yeah.
particular about where you want to bond?
You mean like you drew it on the left? Or? No, that doesn't matter. Okay, how many lone pairs? None, right? Okay, carbon is how many valence? Remember that from the other day? We went over that. 4. Okay, so now to do my picture, what I'm going to do is I'm going to put a dot on one side, 2, 3, 4. And I'm going to walk my way around the element. Okay, so carbon can make how many bonds? 4. This is not telling you what kinds of bonds or any of that yet. It's just telling you that it can make 4 bonds, and it has how many lone pairs? None, right? Okay, now nitrogen. How many valence does nitrogen have? 5. Okay, do you remember how to get it? Because I didn't say that yet. If you look at the column in the periodic table, it's 5A, so it's 5. Okay, or is it like 15? And it's the 5. Okay, now here we go. We're going to take our N, and I'm going to do my dots again. So I'm going to go 1, 2, 3, 4. Now what do I do with the last electron? You double up. So what does this tell me? This tells me how many bonds can nitrogen make? 3. Okay? And how many lone pairs does it have? 1. Okay? So that should help you to remember 3 bonds and 1 lone pair. Now, nitrogen can screw up and break the rule. But when it does that, it is not neutral. Okay? This is neutral. Okay? We'll talk about a few of those other ones as well later on. Okay, oxygen, valence? 6. Okay, so now here's my, I'm going to start drawing my little dots. 1 on each side. Okay, that's 5. Where's the 6th one go? Okay, does not matter if your 2 pairs of electrons are catty corner, opposite, top, bottom, doesn't matter. Doesn't matter. Okay? Okay, but how many bonds can I make with oxygen? How many? 2. And how many lone pairs do I get?
2.
Are we seeing a pattern? Okay. X stands for all the halogens because all the halogens have the same number of valence electrons. So X got used for that. So because of that, we typically will probably never have an element that's just X. Okay? Okay, so how many valence do the halogens have? 7. There's a sad 7. Okay, and then over here, I'm going to do my X. But remember, it can be fluorine, chlorine, bromine, or iodine. Okay, and now I'm going to go 1, 2, 3, 4. Now I start doubling up. 5, 6, 7. Okay, so how many bonds am I going to get out of those halogens? 1. And how many lone pairs? 3. So notice as we went across the table, the number of bonds went down and the number of lone pairs went up. And we're just worrying about the nonmetals. Okay? Any questions on that so far? Okay, this little table thing hopefully will help you to draw the structures. All right, I think I'm going to have to go like that. Okay, so first one we're going to draw is water, which you all know. Okay, but I want to show you how the oxygen will have 2 lone pairs. Hey, this is working pretty good today. Sometimes the pen doesn't like me either. Okay, and then you have hydrogens, 2 of those. Okay, so you see how these guys are going to come together and make a bond, and these guys are going to come together and make a bond. Okay, but we don't draw it with all those dots. We put that line in between. And the thing about Lewis structures is you have to show all the bonds and all the lone pairs. So if you show all the bonds, but you don't show the lone pairs, then you'll lose a point. Okay, like on the test. All right, so just make sure you remember that. I'll try to remind you. Okay, now, if you drew water like this, there's nothing wrong. It's fine. Okay? They're the same thing. All right? This one is a little closer to what it actually looks like. That's the only thing. Okay? Okay. Methane. CH4, another one you might have done before. So carbon will make how many bonds? 4. And we have how many hydrogens? 4. They'll each make 1 bond. So what do? We have a carbon and we have 4 bonds around it. Okay? Do not write it like this, which, yes, I have seen. Okay? So what's wrong with that? Like about a 50 things. Okay? Notice our carbon up here has how many electrons around it? 2, 4, 6, 8. Okay? This carbon down here has only got 2. Okay? And what else rule was broken? The hydrogen rule. Hydrogen only makes 1 bond. Okay? All right, I'm going to erase some of that because I have a feeling I'm going to run out of space. There we go. I feel like there's a lag. Is there a lag? Yeah. Okay. I don't know. Okay, ethane. Have we done this one before? You did? Oh, then y'all got it already, right? Okay, so you're going to have 2. Make it be a pen. Okay. Okay, again, don't put everything in a line. That's the tendency when you start doing these, is to put everything in a line. Don't do that. There's that thing. Is ammonia the last one on that page? Yeah. Okay, good.
There's one more.
There's one more? Oh my gosh. All right, I'll put ammonia over here. Okay, so when you're doing ammonia, now how many bonds does the nitrogen make? 3. And it has a lone pair. So who do you think these 3 bonds are to? The 3 hydrogens. That's right, because hydrogen only gets 1 bond. I should have left myself a little more room. Okay. I don't know how many years I've been doing this. All right, chloroform. Okay. This is the chloroform that, you know, they use in the movies all the time. They put it on the thing and they knock people out, okay, and they kidnap people, okay? But it doesn't work that fast. Yeah, like they hold it over their mouth and like in 5 seconds they're out. You're going to use chloroform in life. None of you are going to pass out, okay? I promise, All right, no one's ever passed out. So now how do you think we're going to do this one? The carbon will make how many bonds? 4. Okay. The hydrogen makes 1. How about those chlorines? They just make 1. Okay, so you're going to have a carbon with 3 chlorines and a hydrogen. And what do you need to remember? Lone pairs. Boom. And each chlorine gets 3 lone pairs, right? Yeah, it is kind of time lagging on me. Okay, that's chloroform. Does it matter if the H is on the left or the top or the right or the bottom? No, it does not matter. That's why I have to grade your stuff, because only Jay-Z will know. Everybody else would be like, what? They wouldn't know that it was right or wrong. Okay, they would think if you didn't write it just like me, it was wrong, and that's not true. There's going to be multiple ways that you can write things. Okay? All right, so we're ready for some harder ones because you guys got this now. Okay, so these are just a little more complicated. Okay, so this one is ethylene. Okay, remember that each carbon will make how many bonds? 4. Okay, each hydrogen will make 1. So what am I going to do here?
Double bond carbons.
Yes, because if you do this, you run out of hydrogens. Okay? If you don't have enough hydrogens to do all single bonds, that means there has to be some multiple bond in there. Okay? Hydrogen does not do multiple bonds because it only makes 1 bond. Carbon, however, will make single bonds, double bonds, and triple bonds. Okay? All right, so let me fix. So how am I going to fix that? I'm going to erase this guy. Whoa. You like really erased it. That's all right. I can put him back. Okay. So between the 2 carbons, I'm going to do this. And then I'm going to put another hydrogen on that carbon. Okay. Notice that each carbon has how many electrons around it? 8. We're going to get to, later on, maybe Friday, we'll get to why it does that. Okay. But carbon is unique among all the elements in that it will make single bonds, double bonds, and triple bonds. And it will make them all mixed up over and over to be huge things. Okay. Remember, we're carbon-based life forms. Okay. All right. So the next one is formaldehyde. How do you want to do that one? Do y'all have a guess?
Carbon double bonded to the oxygen.
Yeah, because carbon will make more than 1 bond. It'll make 4. But oxygen will only make 2 bonds. Okay? Now, these little things are kind of like little puzzles. All right? So if you start playing with the pieces and you go, the carbon didn't get 4 bonds. Okay? So that should tell you that, oh my gosh, something's got to be rearranged. Okay? It should also tell you that there's a multiple bond in there. The only elements in here that can do that are carbon and oxygen. Carbon, oxygen, and nitrogen, and sulfur for that matter, can all make single or double bonds. Nitrogen can also do triple bonds. Okay? All right, so where do the hydrogens go? They go on this C. Doesn't matter if they're up or down. And then you need to put 2 lone pairs on your O. It doesn't matter if you go like this or like that. In here, we generally don't put them where the bonds are. Okay? When you're doing saplings sometimes and you have to put your lone pairs in, sometimes it puts them there and it will count it correct. But don't do that when you draw them because that's just weird. Okay? I don't know why they don't make that thing not do that. But I've gone in and like done the homework that y'all are doing. And, okay. I've done the homework that y'all are doing, and it did it to me, so I assume that it's going to do it to you. I'm sorry, I need to do that. Okay, here's hydrogen cyanide. Okay, hydrogen cyanide. How am I going to put that together? I've only got one H. Okay, so I'm going to go like this. That is hydrogen cyanide that kills people all the time on TV too. It's very poisonous. Don't play with it. I don't know where you would get some, but I don't know. And it always amazes me how the bad people find all this stuff. I'm like, how did they get it? They got a guy. That's probably true. They got a guy. I don't know. I ain't got a guy. Okay. How do you think we'll do acetylene? We only have 2 H's.
3 bonded.
Yeah. So we're going to triple bond our carbons. Is that the last one?
Yeah.
Okay. I thought it was. Okay. There is no 4 bonds between carbons. Okay. Even graphite and diamond, it just spreads out and is bonded to more carbons. Okay. There just isn't C4C, C2. That's just kind of weird. Okay. So that's acetylene. That is acetylene in acetylene tanks and torches and stuff. Okay. All right. Any questions on those? Are you seeing when to figure out about the triple and double bond? That's the biggest thing. Okay. Note that carbon can share 1, 2, or even 3 pairs of electrons with itself or other atoms. Okay, carbon is pretty cool that way. Okay, now let's get to some bigger ones, because you know we ain't going to stick with acetylene. Yeah, no. Oh, no. Okay, here's kind of a way that you can use, a method to do these. Okay, one is determine the number of valence electrons needed in your picture, okay, by adding them up from your formula. Okay, remember that table, although there can be exceptions when something has a charge. That table is for neutral. The number of valence electrons will still hold up. Don't forget the octet rule, and really put the hydrogens in last. Don't let them overwhelm you, because you're going to see you can have a lot of hydrogens. Okay, way more than your numbers of carbons, but put it in last. This is a puzzle, and it's like the hydrogens are like a cul-de-sac. You drove down the road and you can't go any farther now, okay, if you put them in. What's going on? Oh, my puzzle piece. Okay. Okay, so we're going to draw a Lewis structure for C3H8. Okay, so the first thing we're going to do is we're going to calculate the number of valence electrons and add them up. Each carbon gives you how many valence? 4. 4 times 3 is 12. Jump in on those easy questions. All right, so here is 12. And how many do I get from 8 hydrogens? 8, 1 from each. So I should have 20 valence electrons in my picture. Okay, so what do you want me to do? Besides go to lunch, and we're not doing that yet. Okay, so we're going to have a carbon, and what do you want to bond it to? Another carbon. Do all of your atoms except the hydrogens first. If you put the C and you put 4 H's around it, you just dead-ended yourself. You're like on the cul-de-sac, okay? So put all the other elements together first, then worry about the hydrogen. So I got C, C, and a C. C. Okay, now what do I do with my hydrogens? How many do I got? 8. So how many does this one get? 3. And you notice we just go to the 3 quadrants, you know, so 4 quadrants, whatever. Okay, the C in the middle gets 2, and you'll notice we always draw 1 down and 1 up. We don't draw like 2 down, okay? All right, the last carbon gets 3. Okay, did I use 8 hydrogens? Okay, when you're doing these, especially when they get bigger, it's really easy to add extra hydrogens and not realize you did it. So pause and count, okay? And make sure you didn't do that. All right, next thing. Does every carbon have an octet? So you're going to go 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. It doesn't matter that they're sharing. That's the point. Okay, that's why they are sharing, so that they all get an octet. Okay, and did we use a total of 20 valence electrons? So if you count all of them, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, it all adds up. Okay, so those are things you can do to check yourself, make sure you didn't inadvertently throw in extra lone pairs or whatnot. Okay? Had you done that one before? No. Okay, good. All right, CH4O. You might have done this before. We'll see. All right, let's add up the valence electrons. So we're going to have how many from the carbon? 4. How many from the 4 hydrogens? How many from the oxygen? So that's going to be 14. Okay, so make sure you get 14 val electrons. Okay, so how do we want to put this one together?
Carbon bonded to the oxygen.
Yeah, let's take that carbon and let's bond it to an oxygen. Okay. All right, now we have how many hydrogens? 4. So where do they go?
Around the carbon.
Okay, and how many?
3.
3. Don't give carbon more than 4 bonds. And the oxygen gets 1. Doesn't matter if you draw it across, up, or down. Okay, now if I look at this, I've got 2, 4, 6, 8, 10 electrons. I'm supposed to have 14. The oxygen gets 2 lone pairs. And when you do that, the oxygen ends up with how many electrons around it? 8, the octet rule. Okay? Have you done that one before? That one's methanol, wood alcohol. Don't drink it. It causes blindness. I have many tips for you throughout the year. All right, CH5N. CH5N. All right, so what do you think about that one? How many valence is there total? 4 plus 9 plus, how many from the nitrogen? 5, right? 4 plus 9 is?
14.
4 plus 5 is 9. 9 plus 5 is 14. All right, I'm with you now. I'm like, what a minute. Okay. Yeah, where'd the 9 come from? I was probably adding. All right, so how do you think you want to do this one? This is easy.
Carbon and nitrogen.
Carbon to nitrogen, and we're going to put our hydrogens in. This guy gets 3.
Nitrogen gets 2.
And the nitrogen gets 2.
And a lone pair.
Yes, and don't forget your lone pair. Okie dokie. All right, we got some more coming. All right, C2H5Br. C2H5Br. Okay, I tell you what, you guys draw it, and I will build a molecule because I want to show you something. And while I'm building the molecule, you'll get it all done. And then I can talk a little bit about the kit. Yeah, the only problem with the recordings is you don't get to see my models and stuff. Because it's only recording what's on the slides. I guess I could take pictures of all my models and throw them up there, but that just isn't going to happen. Sometimes I have some pictures that are similar or something that I'll use. All right, how'd you do? How many valence electrons did you come up with? Or did you not? Did you just skip that part?
20.
Because you got it. 20? Somebody got 20? Okay. Did you get 20 in your picture? When you drew it? Cool. Okay, does it look something like, that's the next one. why this time lag is kind of, if I start having seizures, you can just call for help. Okay. I actually have had seizures before. Not from this, though. Okay, so is that how you drew it? Did anybody put their bromine on the left? Did anybody put it on the top? Really, y'all did it that way? Because it doesn't matter, okay? So here is the model of that compound, okay? With the orange one is the bromine. It is not to size, okay? And you could have it, see, a million different ways, and they're all the same, okay? You'll also notice when you look at this carbon that, oh my gosh, it is not, it's not flat. When we draw these things on the board, they look flat. They're not really flat, okay? This is the last one, and it's at 11:50. I want you to draw this one for next time, and that will start right here on this slide, okay? That will work. All right, y'all have a good lunch. See you Friday.